Next question is, find the values of a and b if the function f defined by f of x is equal to x square plus 3x plus a if x less than or equal to 1, f of x is equal to bx plus 2 if x greater than 1 is differentiable at x is equal to 1. It is given that given function is differentiable at x is equal to 1. If this function is differentiable at x is equal to 1, then what are the values of a and b? So here we have to find the values of a and b. And we have studied if a function is derivative, if a function is differentiable at x is equal to c, then left hand derivative, that is limit h tends to c, f of c minus h minus f of c divided by minus h, that is equal to right hand derivative limit h tends to c, f of c plus h minus f of c divided by h. Right? So here c is equal to 1. Okay, let's compare this one. Limit h tends to c is 1, f of 1 minus h minus f of 1 divided by minus h, that is equal to limit h tends to 1. It is left hand derivative, it is right hand derivative, limit h tends to 1, f of 1 plus h minus f of 1 divided by h. Okay, now let's substitute. What is f of 1 minus h? See here, listen, it is limit x tends to 1, it is left hand derivative. So here the value is less than 1. Okay, x is less than 1. So here we will take the function is x square plus 3x plus a. When right hand derivative, here x value is very close to 1 but it is greater than 1. Therefore we will take the function bx plus 2. Okay. So here limit h tends to 1, f of 1 minus h. It is the function, okay, because in left hand derivative x is less than 1. Therefore we have this function x square plus 3x plus a. So f of x is equal to this one. Then what is f of 1 minus h? Replace x by 1 minus h. Okay. 1 minus h whole square plus 3 into 1 minus h plus a. It is f of 1 minus h minus f of 1. Substitute 1. 1 square is 1 plus 3 into 1. Okay. 1 square plus 3 into 1 plus a divided by minus h. That is equal to, here it is right hand derivative and here x greater than 1. So we have the function bx plus 2. Okay. So here substitute limit h tends to 1, f of 1 plus h, f of x is equal to bx plus 2. So f of 1 plus h, substitute x is equal to 1 plus h. So b into 1 plus h plus 2 minus, it is f of 1 plus h minus f of 1, put x is equal to 1, it is f of x, put x is equal to 1. So b into 1 plus 2, that is minus b, minus of b plus 2, that is minus b minus 2 divided by h. Okay, then let's simplify this one. Limit h tends to 1. Here 1 minus h whole square, it is of the form a minus b whole square. 1 square plus h square minus 2h plus 3 minus 3h plus a minus 1 minus 3 minus a. Okay, multiplied this minus by all each of these terms inside the bracket. Okay, 1 plus 3 plus a, so minus 1 minus 3 minus a divided by minus h is equal to limit h tends to 1. Here b plus bh plus 2, here plus 2 minus 2 cancelled, then minus b divided by h. It is equal to limit h tends to 1. Okay, next step I will write. Okay, so here see plus 3 minus 3 cancelled, a plus a minus a cancelled, then 1 minus 1 cancelled. So limit h tends to 1 minus 2h minus 3h. that is minus 5h divided by minus h is equal to limit h tends to 1. Here b minus b cancelled. So bh divided by h, hh is cancelled. Okay, bh divided by h. This implies here minus cancelled and h is also cancelled. So we will get limit h tends to 1, 5, that is equal to limit h tends to 1, b. Right? So limit of a constant is nothing but constant itself, right? So here limit of 5, that is 5. So this implies b is equal to 5. Okay? Limit of b itself, limit of 5 itself. So b is equal to 5. We have got value of b. So next we have to find the value of a. How to find the value of a? See here, listen. We have already proved that every differentiable function is continuous function. Right? Every differentiable function is continuous function. So here, if this function is differentiable at x is equal to 1, then this function is continuous at x is equal to 1. Okay? So here, we know that if a function is continuous at x is equal to 1, right hand limit, that is left hand limit, that is equal to right hand limit, that is equal to value of the function. So from there, we will get value of a. Okay, next we have to find value of a, and since this function is differentiable at x is equal to 1, since f of x is differentiable at x is equal to 1, f of x is continuous at x is equal to 1. Okay? Since it is continuous at x is equal to 1, left hand limit is equal to right hand limit, that is equal to value of the function at x is equal to 1. Okay. So here, then left hand limit, that is limit x tends to 1 minus f of x, that is equal to limit x tends to 1 plus f of x, that is equal to f of 1. Okay, it is the definition of the continuous function. Okay, so here let's find left hand limit and right hand limit. So here left hand limit, limit x tends to 1 minus f of x is equal to, here x tends to 1 minus, that means x less than 1. The function is x square plus 3x plus a. So limit x tends to 1 minus x square plus 3x plus a, that is equal to, substitute x is equal to 1, x is equal to 1, so 1 plus 3 into 1, 3 plus a, that is equal to 4 plus a. Okay, then next here, next we have to find right hand limit, that is limit x tends to 1 plus f of x, f of limit x tends to 1 plus means it is value of x is very close to 1 but it is greater than 1. That is, if x is greater than 1, the function is bx plus 2. So limit x tends to 1 plus bx plus 2, that is equal to, substitute x is equal to 1 here. So b into 1, b plus 2. Okay. Since this function is continuous at x is equal to 1, left hand limit is equal to right hand limit. Okay. So here left hand limit is equal to right hand limit. Left hand limit is 4 plus a. We can write here, since f of x is continuous at x is equal to 1, 4 plus a, that is left hand limit is equal to right hand limit. Left hand limit is 4 plus a and right hand limit is b plus 2. Okay. So here 4 plus a is equal to, what is our b? B value is 5. Okay. Value of b is 5. 5 plus 2, that is 7. So a is equal to 7 minus 4, that is equal to 3. So we have got a is equal to 3 and b is equal to 5. Next question is, If cos y is equal to x into cos of a plus y, where cos a not equal to plus or minus 1, prove that dy by dx is equal to cos square of a plus y divided by sin a. Here we have to find dy by dx, right? So here given equation is, given function cos y is equal to x into cos of a plus y. Very simple, differentiate with respect to x both sides, okay? So here given function cos y is equal to x into cos of a plus y. Okay. Differentiate with respect to x on both sides. Differentiate with respect to x on both sides. We get cos y, derivative of cos y with respect to x is derivative of cos y minus derivative of cos x is minus sin x, derivative of cos y minus sin y into derivative of dy by derivative of y, that is dy by dx. So minus sin y dy by dx. Okay, derivative of cos y is minus sin y into derivative of y with respect to x, that is dy by dx. Okay, minus sin y dy by dx. So right side, here product of two functions, so we have to apply product rule. First function x into derivative of cos of a plus y, derivative of cos x is minus sin x, derivative of cos a plus y is minus sin a plus y into derivative of a plus y, derivative of a is 0, derivative of y is dy by dx. Okay, then next term, okay, first function into derivative of second function, next second function into derivative of first function, that is the product rule. So x into minus sin a plus y dy by dx plus second function cos of a plus y into derivative of x is 1. Okay, into 1. Now here, after that we will take dy by dx terms together and solve for dy by dx. Okay, that time you will get this answer. So here minus sin y dy by dx, let's take this one here. See, minus sin y dy by dx, it is equal to minus x sin a plus y dy by dx plus cos of a plus y. Okay, now let's take this term left side. Okay, that is x, it is minus here. Okay, when we take it to left side it will be plus. So x into sin of a plus y dy by dx minus sin y dy by dx is equal to cos of a plus y. Okay, then here in both terms dy by dx is common, so let's take it out. Dy by dx into x sin a plus y minus sin y is equal to cos of a plus y. Okay, then dy by dx is equal to cos of a plus y divided by this one. Dy by dx is equal to cos of a plus y divided by x sin of a plus y minus sin y. Here we have got dy by dx is equal to cos of a plus y divided by x into sin of a plus y minus sin y. Okay. See what we have to prove, dy by dx is equal to cos square a plus y divided by sin a. See in our RHS here no x terms, right? No x terms. But here we have got x in denominator. So let's substitute x terms. Okay, let's change this x to y. How? See what is our equation? Cos y is equal to x into cos of a plus y. So from here we can we can substitute what is y, what is x. So x is equal to, we can find x is equal to cos y divided by cos of a plus y, right? That is our equation is, given equation cos y is equal to x into cos of a plus y. Okay, from this equation we can find x is equal to cos y divided by cos of a plus y, right? Because See here in our RHS no x terms. So here we have to change this x to y terms. Okay, we should get this dy by dx in y terms. Okay, so here we can get what is x. X is equal to cos y divided by cos of a plus y. Now let's substitute x is equal to cos y divided by cos of a plus y here. Therefore dy by dx is equal to numerator cos of a plus y divided by x into, x is nothing but this one, cos y divided by cos of a plus y, okay, into sin of a plus y minus sin y. Okay, see here we have got dy by dx is equal to cos of a plus y divided by x into sin a plus y minus sin y. So we have substituted x is equal to cos y divided by cos of a plus y. Then let's simplify. Here take LCM. It is cos y divided by cos of a plus y into sin of a plus y, right? So take this here, multiply, cross multiplication, sin y into cos of a plus y. So it is equal to cos of a plus y divided by cos y into sin a plus y minus sin y into cos of a plus y. Okay, divided by cos of a plus y. Okay, after taking LCM. So this cos of a plus y will come to numerator. So it will be cos square of a plus y. Okay, so here after taking LCM, cross multiply this one, that is sin y into cos of a plus y. Okay, whole divided by cos of a plus y. That cos of a plus y come to numerator, that is denominator of denominator will come to numerator. So it will be cos square of a plus y. Now what is in denominator? See here, see it is of the form sin a cos b minus cos a sin b. Sin a cos b minus cos a sin b, or we can write sin x cos y minus cos x sin y. We have an identity sin of a minus b. Sin of a minus b is equal to sin a cos b minus cos a sin b. See, it is the form of sin a cos b minus cos a sin b. That is cos square of a plus y divided by, that is nothing but sin a cos b minus cos a sin b is nothing but sin a minus b. What is a? A plus y. Okay, a plus y minus b is y. Okay, that is equal to cos square a plus y divided by y plus y minus y cancelled. So sin a in denominator. So it is the RHS, right? Hence it is proved. Look at the next question. If x into root of 1 plus y into root of 1 plus x is equal to 0 for x not equal to y, prove that dy by dx is equal to minus 1 by 1 plus x whole square. Very important question. Here, see, before going to the solution, see, you have to look at the RHS carefully. Here, what we have to prove? Here, our RHS is only in x terms, right? Our RHS only in x terms. So, see, usually what you will, how you will find dy by dx? See, you will find dy by dx differentiating with respect to x, this equation on both sides, right? So that here, after finding dy by dx, you will get dy by dx as not only in x terms, you will get x and y terms. It will be shuffled, right? X and y terms. But here, after that, you will be struggle to change these y terms to x terms, right? So here we have to simplify this equation in the form of y is equal to some x terms. Okay, y is equal to x terms. After that only you differentiate it with respect to x, so that you will get this your RHS in x terms. Okay, see here, don't be confused. you should practice, okay? You should practice with all these questions and exercise problems, okay? So that it enhances your problem solving ability. Then automatically you will have ideas and tricks to solve the problems. Okay, if you don't practice, see, you will not get any idea how to solve this during exam. Okay, so here you should practice with all these problems, okay, whatever I have given, and with the exercise problems also. Okay, so here take this equation. Here I will write this equation as x into root of 1 plus y into root of 1 plus x is equal to 0. Okay. Here I will take this y root 1 plus x right side, so that here this we can cancel this root, right, for easy simplification. Okay, so x into root of 1 plus y is equal to minus y root of 1 plus x. Okay, then here square on both sides, okay, to cancel this square root. We can cancel this square root very easily, okay, by squaring on both sides. So it will be x square into 1 plus y is equal to y square into 1 plus x. Okay. Now let's simplify this one to get in the form of y is equal to. Y is equal to, in RHS this expression should be only in x terms. Okay. Then only you differentiate it. Okay. Now here x square plus x square y is equal to y square plus xy square. Okay, then let's take all the y terms together. Okay, so here all the terms have y's, right? So here x square minus y square, that is equal to, here take this one, xy square minus x square y. This can be written as xy into, here, y minus x. Okay. And here x square minus y square, that is nothing but x plus y into x minus y. Right? That is equal to xy into, here we can take minus outside, then it will be x minus y. Okay. So one x minus y cancelled. Then it will be x plus y is equal to minus xy. Okay. Then x is equal to minus xy minus y. So that is equal to, take minus y outside. So minus y outside. So it will be x. Or take y outside. So it will be minus x minus 1, that is equal to x. Okay. So here what is y? Y is equal to, take this one here, that is x divided by minus x minus 1, that is take minus outside, it will be minus x divided by x plus 1. See, we have got y is equal to minus x divided by x plus 1. Now it is very easy to find a dy by dx. And this dy by dx will be in only in x terms. Okay. So here be careful before going to the solution. Okay. Here see, you don't have enough time during exam, right? So you should practice. If you practice, you will get, automatically you will get the tricks. Okay. So here we have got y is equal to minus x divided by x plus 1. So what is dy by dx? Now let's differentiate it with respect to x. Okay, it is in the form of u by v. Apply quotient rule. Denominator into, that is x plus 1 into derivative of minus x is minus 1 minus x into derivative of x plus 1 is 1 divided by x plus 1 square of denominator, that is x plus 1 square. That is equal to, here minus x into minus 1 minus x plus 1 into minus 1 minus 1 minus into minus x plus x into 1. Okay. Divided by x plus 1 whole square. Minus x plus x cancelled. So minus 1 by x plus 1 whole square. That is RHS. That is equal to RHS. Hence it is proved. Okay. This one what we had to prove. Okay. So first of all you have to simplify. Okay, you have to simplify to make it in the form of y is equal to x terms. If y is equal to cos inverse of 3x plus 4 into root of 1 minus x square divided by 5, find dy by dx. So here given function is inverse trigonometric functions, right? So how to find derivative of inverse trigonometric functions? Okay, so here our function is cos inverse of 3x plus 4 into root of 1 minus x square by 5. See here, you should be careful about, you don't differentiate it directly. Okay, if you differentiate it directly, you will not get the answer. So here we know that as usual here inverse trigonometric functions, so we will put x is equal to an appropriate trigonometric function to get an identity, right? Some trigonometric identity, right? So here, see, root of 1 minus x square. We know that 1 minus sine square theta or 1 minus cos square theta, it will be sine theta or cos theta. Okay, so let's put, see, why we will put x is equal to some trigonometric functions to cancel this cos inverse. See, here we have to make it in the form of cos of some value. Okay, cos of. So we have to make this inside bracket, inside of this cos of, right? So for that, here put x is equal to sine theta, or you can put x is equal to cos theta also. Okay, so that you will get, see here, 1 minus cos square theta, that will be sine theta, or 1 minus sine square theta, it will be cos theta. Okay, put x is equal to sine theta. Then, so y will be cos inverse of 3 sine theta plus 4 into root of 1 minus sine square theta divided by 5. That is equal to, here cos inverse of 3 sine theta, I will write 3 by 5 sine theta plus 4 by 5, what is root of 1 minus sine square theta? Root of 1 minus sine square theta is cos square theta. So root of cos square theta is cos theta. Okay, then here, see, there is no such identity in our trigonometric functions, right? So here what we have to, which method we will apply? See here, put 3 by 5 is equal to sine alpha, okay, or cos alpha, sine alpha, okay. See here we have to make cos, right, cos of. So what is our cos A plus B? What is cos A plus B? Cos A cos B minus sin A sin B. But here plus, so let's take cos A minus B. Okay, what is cos A minus B? Cos A minus B is cos A cos B plus sin A sin B, right? So if we put 3 by 5 is equal to sin alpha, then we will get it in the form of this one, right? So let's put 3 by 5 is equal to sin alpha, okay, and 4 by 5 is equal to cos alpha, okay. Then, so it will be, so y is equal to cos inverse of 3 by 5 is sin alpha sin theta plus cos alpha cos theta. See, now it is in the form of cos A cos B plus sin A sin B. Cos A cos B plus sin A sin B. Cos A cos B plus sin A sin B is nothing but cos of A minus B. That is cos inverse of cos of, here what is alpha minus theta, okay, alpha minus theta. Now it is nothing but cos inverse of cos x is nothing but x, right? Cos inverse of cos x, cos inverse of cos x is nothing but x, right? So here cos inverse of cos of alpha minus theta is nothing but alpha minus theta. Okay, so what we have got? Y is equal to alpha minus theta. What is our theta? X. We have put x is equal to sin theta. That implies theta is equal to sin inverse x. Okay. Now that is equal to alpha minus sine inverse x. Okay, now let's differentiate. Y is equal to alpha minus sine inverse x. That implies dy by dx is equal to, what is alpha? Here we have put 3 by 5 is equal to sine alpha. So alpha is nothing but sine inverse of 3 by 5. Sine inverse 3 by 5, that is nothing but a constant. Right? Sine inverse 3 by 5 will be a constant. Right? So here when we take a derivative of constant, it will be 0. Right? So therefore derivative of alpha will be 0. Then minus d by dx of sine inverse x. That is minus d by dx of sine inverse x is nothing but 1 by root of 1 minus x square. Okay. So minus 1 by root of 1 minus x square. So it is our dy by dx. dy by dx is equal to minus 1 by root of 1 minus x square. Differentiate tan inverse of root 1 plus x minus root 1 minus x divided by root 1 plus x plus root of 1 minus x. Okay, so let's take y is equal to tan inverse of root 1 plus x minus root 1 minus x divided by root 1 plus x plus root 1 minus x. We have to find dy by dx. So here also given function is inverse trigonometric function. So here let's substitute, let's put x is equal to some trigonometric identity. Okay, see here x is equal to, see it is in the form of 1 plus x, right? Root of 1 plus x, root of 1 minus x. See, and we have an identity 1 plus cos 2 theta. Here we should get tan, right? Tan of something. Okay. So 1 plus cos 2 theta, that is equal to 2 cos square theta. We have an identity 1 plus cos 2 theta is equal to 2 cos square theta, and 1 minus cos 2 theta is equal to 2 sin square theta. Okay. So here if we put x is equal to cos 2 theta, then we can remove this square root, right? So after the simplification, let's see what we will get. Okay. So here put x is equal to cos 2 theta. Okay. Here don't put x is equal to cos theta. If it is x square, here we cannot simplify. Okay. If it is root of 1 minus x square, you can put x is equal to sin theta or cos theta. After simplification you will get. Okay. But here it is root 1 plus x and root 1 minus x here also. Okay. So let's put x is equal to cos 2 theta. Okay. Then what is theta? Cos. Here 2 theta is equal to cos inverse of x, right? 2 theta is equal to cos inverse of x. Theta is equal to 1 by 2 into cos inverse of x. Okay, now let's put this one. Here y is equal to tan inverse of root of 1 plus cos 2 theta minus root of 1 minus cos 2 theta divided by root of 1 plus cos 2 theta plus root of 1 minus cos 2 theta. Okay, then here we have identities. 1 plus cos 2 theta is 2 cos square theta, 1 minus cos 2 theta is 2 sin square theta. So let's substitute it here. Tan inverse of root of 2 cos square theta minus 1 minus cos 2 theta is 2 sin square theta, root of 2 sin square theta divided by, okay, same in denominator, root of 2 cos square theta plus root of 2 sin square theta. Okay. See, root 2 is common in all terms, right? So we can take, root 2 outside from numerator and root 2 take outside from these two terms in denominator. So it will be cancelled. Okay, root 2 is cancelled. Then here tan inverse of root 2 is cancelled, right? So square root of cos square theta is nothing but cos theta. So we will get, after taking, removing square root, so here square root of cos square theta, that is cos theta, minus sin theta divided by cos theta plus sin theta. Okay? Cos theta minus sin theta divided by cos theta plus sin theta. Okay? Now, here, see, we have to make tan of, right? Tan of this one. Okay? Some expression. So, here, we have got cos theta minus sin theta divided by cos theta plus sin theta. So, how to make it tan? See here, let's divide cos theta. Okay? Let's divide throughout by cos theta. So that we will get 1 minus sin theta by cos theta, that is tan theta. So it will be in the form of tan A minus tan B divided by 1 plus tan A into tan B. That is nothing but tan of A plus B, or tan of A minus B. Okay. That is equal to, here, tan inverse of, okay, let's divide throughout by cos theta. So cos theta by cos theta, that is 1. Should I write or not? Okay, cos theta by cos theta minus sin theta by cos theta divided by cos theta by cos theta plus sin theta by cos theta. Okay, that is equal to tan inverse of 1 minus tan theta divided by 1 plus tan theta. Now, see here. Here 1 can be written as tan pi by 4. Okay, 1 can be written as, because tan pi by 4 is equal to 1, right? So it will be in the form of tan pi by 4 minus tan theta divided by tan pi by 4, okay, plus tan pi by 4 into tan theta, right? Because tan pi by 4 is 1, okay? So that is 1 minus tan theta divided by 1 plus 1 into tan theta, that is tan theta. So it is 1 minus tan theta divided by 1 plus tan theta. So what is this one? We have an identity tan x minus y, or yes, tan x minus y is tan x minus tan y divided by 1 plus tan x into tan y. Okay. So here this one can be written as tan of pi by 4, here x is pi by 4, y is theta, therefore it is nothing but tan pi by 4 minus theta, right? So it is nothing but 1 minus tan theta divided by 1 plus tan theta is tan pi by 4 minus theta, okay? So we have got y is equal to tan inverse of tan pi by 4 minus theta. Okay, there. That is equal to, now what is this? Tan inverse of tan pi by 4 minus theta, that is nothing but pi by 4 minus theta, because tan inverse of tan x is x itself, right? So here it is pi by 4 minus theta. What is our theta? Theta is pi by 4 minus 1 by 2 into cos inverse of x. Now let's differentiate with respect to x. So dy by dx is equal to, derivative of pi by 4 is, it's a constant, its derivative is 0. Then minus 1 by 2 into derivative of cos inverse is minus 1 by root of 1 minus x square. So this minus cancelled. So that is 1 by root of 2 into root of 1 minus x square. It is our dy by dx. If y is equal to x into cos inverse x divided by root of 1 minus x square minus log of root 1 minus x square, then prove that dy by dx is equal to cos inverse x divided by 1 minus x square whole raised to 3 by 2. So here y is given and we have to find dy by dx. We can differentiate it directly. Okay. So let's differentiate it with respect to x. Dy by dx is equal to derivative of first term minus derivative of second term. Okay. So derivative of first term, it is in the form of u by v. So we will apply quotient rule. that is denominator into root of 1 minus x square into derivative of numerator. Here we will apply product rule because it is the product of two functions. So x into derivative of cos inverse x is nothing but minus 1 by root of 1 minus x square plus cos inverse x into derivative of x. Cos inverse x into derivative of x is 1. Okay. Next, second term. Okay, derivative of first term here. This one is nothing but that is quotient rule. Denominator into derivative of numerator, that is done. Next, numerator into x into cos inverse x into derivative of denominator. See, derivative of denominator, derivative of root x is 1 by 2 root x. Derivative of root 1 minus x square is 1 by 2 root 1 minus x square into derivative of 1 minus x square, that is minus 2x. Whole divided by here square of denominator root of 1 minus x square whole square, that is 1 minus x square. So derivative of first term is done. Next, second term, derivative of second term. Derivative of log root 1 minus x square. Here derivative of log x is 1 by x. So 1 by root 1 minus x square. Then derivative of root x, that is 1 by 2 root x, 1 by 2 root 1 minus x square into derivative of 1 minus x square minus 2x. Okay, so applied chain rule. First taken derivative of log, then root x, okay, square root, then derivative of the function, inside function, okay, 1 minus x square. Okay, then here let's simplify. So you should be careful when you simplify this. Root 1 minus x square, let's multiply this root 1 minus x square by each of these terms. So here it will be minus x root 1 minus x square. Okay, before that, see here we have to take LCM. Okay, okay, let's do later. X into root 1 minus x square divided plus, okay, so here take LCM. It is 1 minus 1 by root 1 plus 1 minus x square plus cos inverse x. So take LCM, so it will be cross multiply. So root of 1 minus x square into cos inverse x, and multiply this root 1 minus x square. So root of 1 minus x square whole square. So it will be 1 minus x square into cos inverse x. Okay. So here root 1 minus x square into this first term. So minus x by root 1 minus x square divided by root 1 minus x square. Okay. Then here cross multiplied. Then minus, here 2 cancelled and minus minus become plus. So x into x, x square cos inverse x divided by root 1 minus x square. Minus, so this one, okay, here, okay, here whole divided by 1 minus x square is here. Then it is 2 cancelled, minus minus become plus. So x divided by root 1 minus x square into root 1 minus x square is 1 minus x square. So here denominators are same, right? So let's take this denominator to this denominator. Okay, it is the denominator of numerator, so it will come to the denominator. Okay, so it is equal to minus x root 1 minus x square plus 1 minus x square cos inverse x plus x square cos inverse x divided by root 1 minus x square into 1 minus x square plus x divided by 1 minus x square. Here, see in both terms, here root 1 minus x square in denominator, root 1 minus x square into 1 minus x square. Here only 1 minus x square. Let's take LCM. So we have to multiply root 1 minus x square here. So it will be minus x root 1 minus x square plus 1 minus x square cos inverse x plus x square cos inverse x plus x into root 1 minus x square divided by root 1 minus x square into 1 minus x square. What is root 1 minus x square? That is 1 minus x square whole raised to 1 by 2. Root x is nothing but x raised to 1 by 2, right? So here 1 minus x square 1 by 2 and 1 by x square, that is power 1. So root 1 minus x square into 1 minus x square is, that is 1 by 2 plus 1. So 1 minus x square whole raised to 3 by 2. Okay, adding the power. Okay, that is here a raised to x into b raised to y, a raised to y, that is nothing but a raised to x plus y, right? So here 1 minus x square whole raised to 3 by 2. Okay, 1 by 2 plus 1. Then here it is minus, okay, minus x root 1 minus x square plus x root 1 minus x square cancelled. Then in both terms cos inverse x is common, so let's take it outside. So it is equal to cos inverse x into 1 minus x square plus x square, 1 minus x square here plus x square divided by 1 minus x square whole raised to 3 by 2. Here minus x square plus x square cancelled. So cos inverse x into 1, that is equal to cos inverse x divided by 1 minus x square whole raised to 3 by 2, that is equal to RHS. Hence it is proved. dy by dx is equal to cos inverse x divided by 1 minus x square whole raised to 3 by 2. Next question is, if y is equal to sin x whole raised to x plus sin inverse root x, find dy by dx. See here, given function, the first term is of the form f of x raised to g of x, right? So here we will apply logarithmic differentiation. So first of all, let's differentiate this one, okay? Let's differentiate it separately, okay? So let's take u is equal to sin x whole raised to x and v is equal to sin inverse root x, okay? U is equal to sin x whole raised to x and v is equal to sin inverse root x, okay? Then what is y? Y is equal to u plus v. Therefore here we have to find dy by dx. dy by dx is equal to du by dx plus dv by dx, right? Then let's find du by dx. Applying, taking log on both sides. What is our u? U is equal to sin x whole raised to x. So take log on both sides. So it will be log u is equal to x log sin x, right? Because log of sin x raised to x is in the form of log x raised to n. Log x raised to n is n log x, right? Log x raised to n is equal to n log x. So here directly we can write x into log sin x. Okay. Then differentiate it with respect to x. Derivative of log u 1 by u du by dx, that is equal to, here apply product rule, x first function and log sin x is the second function. So x into derivative of log sin x is 1 by sin x into derivative of sin x cos x, that is equal to x into cos x by sin x is cot x. Okay, so here du by dx is equal to, take u right side, so u into x cot x. So what is our u? U is sin x whole raised to x into x cot x. Okay, so we have got du by dx. What is dv by dx? dv by dx is equal to sin inverse root x. We know what is the derivative of sin inverse x, that is 1 by root 1 minus x square. So in place of x we just put root x, okay? That is, and find the derivative of root x, okay? So derivative of sin inverse x is 1 by root 1 minus x square. So here root x whole square. So root x whole square is nothing but x, okay? Into derivative of root x is 1 by 2 root x. That's all, okay? That is dv by dx, v is equal to sin inverse root x. So derivative, here we can find the derivative directly, okay? Because it is the very simplest expression, right? So sin inverse root x. So we know that sin inverse root derivative of sin inverse x is 1 by root of 1 minus x square. So here sine inverse root x is 1 by root 1 minus root x whole square, that is x, okay, root 1 minus x into derivative of root x, that is 1 by 2 root x. So here that is nothing but 1 by 2 root x into 1 minus x, okay. Root x into root 1 minus x is root of x into 1 minus x. That is, therefore dy by dx is equal to du by dx plus dv by dx. So du by dx is this one, sin x whole raised to x into x cot x plus 1 by 2 root x into 1 minus x. That's all. It is our dy by dx.